All right, we are going to walk through the 5.1 to 5.4 study guide for the quiz. All right, now this problem we did in class, but let's look at it. Why don't I group all the things together that can go together? So first I have an x squared, and over here on the bottom I have an x to the negative fourth. I have only one constant, so I'm going to leave that there. And then I have y to the negative third, y squared on the bottom. There's all my terms. So I'm going to take one piece at a time. What do we do with exponents in a quotient? We subtract them. 2 minus a negative 4 means we will have x to the sixth in our numerator, right? The 3 will stay in our denominator. These two go away, and I really need an answer without any negative exponents. So the negative exponent here will take this, move it to the bottom as y to the third. So there's my answer, okay? Next we're going to multiply. That's what we're doing here. I should have been more obvious, but if we distribute across each of these, we have negative 6 x to the sixth, right, plus 8 x to the fifth minus 2 x to the fourth. That's, I want to say, a simple distribution, but you have to work with your exponents. All right, in this case, we can put 2 of these, FOIL 2 of these, and then multiply the last one after we get this together. So if I FOIL, I have 2b squared, outer would be minus a b, inner would be minus 4b, last is plus 2. I'm going to collect like terms before I do any more multiplication. Negative b plus 1. So now I'll distribute, right? I have to make sure every one of these terms in the first three hit each of these terms. So I'll start with the negative 2. Negative 2b squared times the negative b gives me negative 2b to the third. And 2b squared times 1 is plus 2b squared, right? Now I'll move down to the negative 5b. Negative 5b times negative b is a plus 5b squared. And notice that I'm collecting like terms as I go. Then the negative 5b times 1 is negative 5b. Now 2 times negative b is negative 2b. 2 times the 1 is plus 2. Right? If I do this and I collect like terms, and I made the columns, it made my life easier, didn't it? All right, that's the answer if we multiply all those binomials together. Now, when it talks about determining end behavior, when x gets really, really large or really, really small, the only term that is going to truly affect is the highest exponent. So we need to look at what happens to negative x to the third as, in the first case, as x goes to infinity. So if I put a really large number in here, let's say I even have 1,000,000, right? Well, 1,000,000 to the third is just a bigger positive number, and then it's got a negative in front of it, so this is things heading to negative infinity. But if instead I plug in negative 1,000,000, a negative number raised to the third is still a negative number, very large negative number, and then if I take the negative of that, it's a positive very large number, so that one heads to infinity. All right, factoring completely. Let's think of the things we do know. We want to talk about any time we can pull out a common monomial, right? 2, 3, these are all equally weighted, but the special products where we have the sum and difference of cubes that we can factor, this would be factoring by grouping, right? And this one is looking at things as if they were quadratics and using our tools that we had for quadratics. So if you have two terms in what you're trying to factor, you might talk about special products, which really are a to the third plus b to the third equals, right, a plus b, a squared minus ab plus b squared. And then we have a similar one for the negative. So if you have two terms, I would look at that. We also have difference of perfect squares, not to forget. Factoring by grouping is if we have 4 terms, what do we do? And then quadratic looks like what we're used to, seeing 3 terms. So when I look at number 1, and actually they're all numbered 1 because I copied them in here, I'm going to see that I can pull out a common monomial term of 9m cubed. And what's left? I have 6m cubed plus 2m plus 1. Well, it turns out I cannot factor this any further. So this is my answer. All right? Okay, the next one. Notice 2 terms. I'm going to look at my special products. Well, it turns out I have a sum of cubes. So I'm going to figure out what's actually cubed here. It's 2c. And what's actually cubed here, it's the 7. So I fill it out according to this up here, and it says, okay, a plus b. I take a squared, 4c squared, minus ab plus b squared. All right, that's it. That's all you have to do for those cubes. The important thing is making sure you know what's cubed here and what's cubed here. Moving on. All right, notice 4 terms that I cannot combine. So I'm going to have to use factoring by grouping. So I'm going to see what's common in this first set, and I see that it's 25s squared, and what I have left is s minus 4. Well, let's see if I can get the same denominator, or excuse me, the same parentheses on the other side. What if I pull out a negative 1? I get s minus 4. So this ends up looking like 25s squared minus 1, s minus 4. Well, guess what? 25s squared minus 1, what does that look like? It's actually a difference of perfect squares. This becomes 5s minus 1, 5s plus 1, s minus 4. Okay? The next one. Again, our go-to is you have to see if there's a common monomial factor. And in this case, we can pull out a 3 and an x. And what we have left is 5x to the 4th minus 24x squared minus 36. All right, well, I have 3 terms. I think I can treat this as a quadratic. Let's say I substitute y anywhere I have x squared. So this becomes 5y squared, right, minus 24y minus 36. Now, let's go back to the tools we had in chapter 4. We multiply a times c, so 5 times negative 36 equals negative 180. And what factors of negative 180 add up to negative 24? Happens to be negative 30 and 6. So I'm going to expand that middle term. 5y squared minus 30y plus 6y minus 36, and factor by grouping. All right, I can pull a 5y out here. And over here I can pull out a plus 6. So we end up with 5y plus 6, y minus 6. Now I substitute back in that x squared. 5x squared plus 6, x squared minus 6. And then I don't forget this factor I pulled out earlier, 3x. So there is the complete factoring completely for that problem. Okay? Now it says let's find our solutions. So we know how to do this. We did this with quadratics. Now we're just doing it for higher level polynomials. My go-to, see if I have anything in here I can factor out. Turns I can pull out a y squared. All right, that's factored completely. So I take each factor, set it equal to 0, don't I? Well, in this case, y squared equals 0, y equals 0, y minus 5 equals 0, solve for the y and I get 5. Those are the answers there. Okay, 4 terms in this one. Got to use factoring by grouping. All right, I can pull out a g squared. I'll have a g plus 3. I'm going to pull out a negative 1 in order to get a g plus 3 down here. So this becomes g squared minus 1, g plus 3 equals 0. Well, I can factor this. This is a difference of perfect squares, isn't it? and I'm going to set each factor equal to 0 and solve for g. So g equals 1, -1, or -3. All right, stop and do this on the paper if you need to make sure you have it, okay? All right, here's another one. Remember, before we factor or solve, we got to get everything to one side. So I'm going to do 4w to the 4th plus 40w squared minus 44 equals 0. And I can factor a 4 out of this. W to the 4th plus 10w squared minus 11. Well, when I'm solving, I can divide by a constant. I cannot divide by anything that has a variable. By variable. Cannot do it. Right? Only if it's a constant. So w to the 4th plus 10w squared minus 11. Well, I could substitute, or I could notice that this is quadratic. So w squared, w squared. So what factors of -11 add up to 10? Well, guess what? That's plus 11 minus 1. So I'm going to set each of these equal to 0. W squared equals -11. Take the square root of both sides. W equals the positive and negative square root of 11. Because it had a -1 under there, I have an I. Over here I have w squared minus 1 equals 0. W squared equals 1. W equals the positive and negative square root of 1, which is positive and -1. It's very important that when you take the square root, you don't forget this. That'll throw everything off. So in this case, I have 4 solutions, which is what I expect. 2 happen to be imaginary, 2 are not. All right, let's look at this next one. X to the 6th minus 4x to the 4 minus 9x squared plus 36 equals 0. I have to do that before I can do anything else. All right, notice 4 terms. 4 terms that I can't put together. I got to do factoring by grouping. All right, I can pull an x to the 4th out, which leaves me x squared minus 4. What can I do here? I think I can pull a -9 out. Leaves me x squared minus 4. All right, so that will be x to the 4th minus 9, x squared minus 4. Well, when this looks like I can treat this as a quadratic, as if it's a difference of perfect squares. X squared minus 3, x squared plus 3, and this is the difference of squares. X minus 2, x plus 2. So let's figure out what our answers are here. Well, on this side we know x can be a 2 or a -2. So we have 2 of them. We should end up with 6 answers, right? So if I come over here and I say x squared minus 3 equals 0, x squared equals 3, x will equal plus and minus the square root of 3. There's 2 answers. Let's look at this one. X squared plus 3 equals 0, x squared equals -3. Take the square root of both sides. X is going to equal positive and negative square root of 3i, because we had a -1 under there. So there's 2 solutions, there's 2 solutions, there's 2 solutions, for a total of 6. All right, I'm going to stop here and do the rest on a second video.